quiz is due Friday. I don't have a whole lot of rules to take home quizzes. You have to turn it in on time and it has to have work. If it doesn't have work, you don't get points for it, and if it's late, I take points off for every day it's late. Okay, obviously with the exception of someone who's absent and they can get another day. So it's due Friday. I don't care if you're, not here tomorrow. If you're here Friday, you're turning it in Friday. Otherwise, if you're sick or something Friday, then you can turn it in Monday. We're going to take our test Monday. We'll review all of this again on Friday. Today we're just doing some more word problems. So there might be a couple of questions on your take-home quiz that'll be a little bit similar to these. So hopefully this will help clarify a little bit of that. If you want to use help, that's fine on your practice quiz. I just can't help you, and you can't use a teacher here at L&P. Okay, so if you want your tutor to help you with it, if you want to work with someone, that's fine. You just have to show work. And keep in mind that you do actually want to understand it. So don't be just copying someone's work, because ultimately you'll be taking the test on it and you want to know how to do it. Okay, so I don't want to see you copying it in my classroom. That's not okay either. You can work with someone, but please don't just blatantly copy it. That's not going to help anyone. All right, so this first question, so we're going to do this one together, is one of the carbon-14 half-life questions. Do make sure you can do this question. I'm going to give you shorter way to do this question, and that's to calculate R. So to find R, you can take the natural log of 1/2 and then divide by the half-life years, and that gives you R. If you can remember this, you can save a little bit of time for this question. This will work for any question that it gives you a half-life. So see how it says the half-life is 5,730 years? Yeah. There are other questions that also give you half-life. So you can calculate the R using the number of years they give you for half-life. So since they give us 5,730 years for half-life, we're just going to take the natural log of 1/2 and divide by 5,730, and that's going to give us R. So we need a calculator because it's going to be a decimal.
I don't care if I do how to stay quiz on my equipment.
And I mentioned this to you yesterday. If the number is really small or really big, your calculator might put this in scientific notation. Do you see the E?
Yeah.
E is like times 10. So this means negative 1.2096 blah 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 times 10 to the negative 4. So what you need to do is move the decimal place 4 times to the left. It's left because it's negative 4. If it said E and then 4, you'd move it 4 times to the right. So instead of 1.2, you're just going to move that point 1, 2, 3, 4 times to the left.
So it's 0.000.
So you have to add some zeros. Let's use 0.00012. If you put more decimals in there, your answer will vary a little bit. So just use that. No, just show your work. No, so that's the rate. So you use the half-life to calculate the rate. Then you use the rate to see how old the fossil is. So this is part 1. It helps you find R. Now we're going to answer the question. So it says, a fossil contains 27% of its original carbon-14. So it's decayed from 100% to 27%. So that's 100% decaying to 27%. So just a reminder, we're using this formula. Pert. Okay, it's gonna decay with this rate that we found earlier, negative 0.00012. It's negative because it's decaying as opposed to growing.
Is that 0.27 or?
Yeah, because I did 100% like 1 and then 0.27.
But we could have had it 127.
Yeah, you can do 127.
Yeah.
So then your first step would be to divide by 1, which doesn't really do anything. If you choose 127, your first step would be to divide by 100, and that would still give you like what I have here. Okay, then we need to solve for t, so I need the e to go away. So how do I get the e away? So I'm going to take the natural log of both sides because natural log and e cancel. So I get the natural log of 0.27 equals that really long decimal, negative 0.00012 t. And then I'm still trying to solve for t, so I'm going to divide by that decimal. And that gives me some number. Let's see what it is. Alright, so about 10,911 years. That's how old the fossil is. That's so old.
It's
So
like
old.
10912.
Seriously? You're a piece of work.
Approximately. Alright, so put this somewhere. Remember this for calculating half-life. Questions on that question? It says, in the year 2000, the cost of tuition was $12,000 per year. So the tuition in the year 2000 was $12,000. Then in 2007, it grew to $15,000. So assuming it's going to keep exponentially increasing, we want to know what tuition will be in 2018. We're going to use the things that I highlighted to find the rate, the R, first. So in 2000, that's like our oldest year. So that's going to be our initial amount. So the initial tuition is $12,000. So that's our P. Principal. We don't know the rate. We know that it grew to 15,000. So how long did it take for it to grow to 15,000? 7 years. So that's my time.
Is the R and T on the first like the first formula? Is it like as a power?
Yeah. Yeah, it's an exponent. So it started at 12,000, it grew to 15,000, and it did that in 7 years. So you guys see where I'm getting these numbers from? So now we're just going to solve this. So what would I do to solve?
Divide 12,000 by 12,000.
Yeah, so divide 12,000. It's a 7. Yeah.
Now why is it 7?
Because it took 7 years to grow to $15,000 because it said in 2000 and then again in 2007.
Okay.
Yeah, so I'm just counting the years. Alright, so divide by 12,000, so I'm going to get, yeah, 5 over 4.
No.
Now what?
ln,
Yep, ln.
and then it's ln 5/4.
So the natural log of 5/4 equals
7r.
7r,
Divide by 7.
and then divide by 7.
I don't know the answer.
We'll find out.
Okay.
When you type it in your calculator, make sure that the divided by 7 part is outside the parentheses. See? So you get 0.032-ish. this is not the answer to the question. So now that we have R, now we're gonna predict what tuition will be in 2018.
This is easy.
So again, we knew that it started at $12,000 and it grows, now we know the rate. Okay, how many years will it be between 2000 and 2018?
That's what we gotta find. I'm gonna say
18 years.
18 years. So that's my T. And we are finding P of 18, which is what tuition will be in 2018. So this piece right here is representing tuition in 2018.
We technically do 11 years and then have
No.
Where'd you get a lot?
Once you have an initial amount, you can't change it. Because this model only works with the initial amount, 12,000. So we got 12,000 e to the 0.032 times 18.
Wait, so the 2007 15,000 is just for the first equation?
Correct. We just use that to find out how fast it's increasing.
ooh, my
Okay, so about $21,346.90. R. Shh. To calculate R, you're going to use 39.4 for the initial amount, and we know that it grows to 2,153.9, and it does that in 56 years. So we're plugging in 56 for T, and then we're going to solve for R. So I'm going to start by dividing by 39.4. And then to get rid of E, I'm going to take the natural log of both sides. Also, I'm not dividing yet. I'm just going to leave it as that fraction. The more you round, the less accurate your answer is going to be. So I'm just going to wait until the end to plug everything in. Because if you round too early, your answers are going to be super different and rounded off. Okay, but if you did, that's okay, just in the future. And then last thing, we'll just divide by 56. So natural log of this thing, and then all of that over 56 is going to be R. So type it all in at once. So you can do the fraction button, 2153.9 over 39.4, and then after the parentheses divided by 56. So I got 0.071. If you get something close to that, maybe slightly different, it could be because you rounded early. Just make sure you show your work so I know where your numbers came from. So once we find our rate, we're gonna answer the question. It says, when will the budget be $3 billion? So we're gonna do this process again. We want to know the initial budget was 39.4 billion. It's gonna grow with this R for a certain period of time and eventually grow to 3,000 billion or 3 trillion. So we're plugging in 3,000. We know our rate. We're finding time. This doesn't change. Once you use the initial amount, it stays your initial amount. You don't change it. Okay. Alright, so then to solve, we'll divide by 39.4. So I get 3,000 over 39.4 equals e to the 0.071 t. Then I'm going to take the natural log of both sides so I can get rid of e. So natural log of 3,000 divided by 39.4 equals 0.071 t. And then I'm just going to divide that by 0.071 to get time. So similar to how I did the last one. 3,000 over 39.4 and then all of that over 0.071. So got 61-ish. Because it says when, I want to actually answer when. So Scoot over, little guy. Okay, so if we get 61 years, I'm gonna add that back on to 1950. Okay, and so that gives me the year 2011. So in 2011, the budget will be $3 trillion.
How'd you do that? All you do is what?
I just added the time back to 1950 because it's
Would be
technically
nice.
like 61 years after 1950 that we predicted that. Start with
Wait, so is this like the opposite of what we've been doing?
kind of. If we start with 600 milligrams, in order to decrease this by 29%, the math we have to do is we have to first take 29% of 600. Okay, so that's 174.
Wait, 0.29 times 600?
Yeah, that's
Yeah.
29% of 600. And then see how it says decayed by 29%? So that means we want to take that away from 600. So we're taking 29% away from the original amount. And that's going to give
Why is it
us.
174?
Huh?
Why is it 174?
I don't know, because that's what it is. That's what 0.29 times 600 is. So to decrease 600 by 29%, you're taking 20.29 and multiplying it by 600, and that's what gives you the 174. Then you're taking that away from 600. So 426 milligrams, that's what's left
Oh, it's like
after
really easy.
1 hour.
Oh, never mind. Oh no, then you just multiply then. No, you don't. Oh, I don't.
We need to know what it decreased to in order to calculate R. So now that we know what it decreased to, we're going to set up our equation. So we know that 600 milligrams decreased to 426 milligrams after 1 hour. So when time is 1, 600 goes down to 426. And again, we found 426 by taking 29% away from 600. Okay, so now we'll solve. So first step to solving is what?
Put it in a calculator.
No.
Put it in a calculator.
Divide by 600. Okay, so you're going to divide by 600. That's going to give you 0.71 equals e to the r. Now what? ln. Natural log, natural log.
Yeah, yes you did.
So the natural log of 0.71, that's my r. That gives me negative 0.342.
Yeah.
I don't think they're
Alright, then it says how much ibuprofen will remain after 7 hours. So now that we know the rate, we know that we started with 600. Let's plug in our rate. And we're going to plug in a time of 7 hours. And then we're just going to type in all of this stuff over here, the right side. So 600 e to the negative 0.342 times 7 gives us 54.758 milligrams.
That's fun.
That's what's left after 7 hours, which isn't a lot. In 1 hour, you're going to take 120 milligrams and subtract 12% of 120 milligrams. So that's 120 minus 0.12 times 120. and that's 105.6.
Tough.
And you're going to use that to calculate the R. So you'll divide by 120, and that's going to give you 0.88. And then you'll take the natural log of that to get R. And that gives you negative 0.128. Then it says how long before the effects wear off. So it says to about 50 milligrams. So we want to know when 120 decays to 50. And we know we have to use this rate. So we solve. So first thing you'll do is divide by 120, and you get 5/12. Then you take the natural log of both sides to get rid of e. And then you divide by negative 0.128. And you get 6.8, not 8, yeah, 6.84-ish, and this is hours. So in about 7 hours, you need another cup of coffee.
Yeah.